All right. Hi, my name is Grant McDonald,
And my name is Margaret Fairborn.
and today we're going to present to you our poster for Whitworth's High Altitude Balloon Tracking System, the project we've been working on this summer. So just as an overview of the timeline of the project, in 2008, Whitworth purchased a high altitude balloon system from StratoStar to conduct student research on the atmosphere. And this system was kind of limited with its features, and also it wasn't very cost effective to use, so Whitworth set out to design its own high altitude balloon system. And in 2017, Whitworth designed version 1 of their high altitude balloon system in an attempt to reduce the cost, increase the performance, and increase the accessibility for students over the stratosphere model. This version 1 had 5 successful flights, however it still did have some issues. So in 2020, Whitworth started developing version 2.0 with aspirations of improving on previous versions. However, progress was halted because of the pandemic in 2020. But again, in 2021, the project was revived and work on the new model continued. And so version 2.2 is the most current version, and that is the version that we have been working on.
So our objectives for this summer were to make the command module smaller and lighter, to replace some obsolete components that had either fallen out of favor because you couldn't find them during the part shortage or just because they'd aged. We also wanted to improve electrical connection reliability in the command module. Version 1.0 had a lot of wires connecting some of the components, and so we reduced the number of wires because wires tend to fray and can cause problems with different printed circuit boards. We also wanted to add a persistent memory system. This would allow the command module to know whether it's in flight, on the ground, or completed its mission, about to start, depending on what was in the memory. And this would help if it did, by any chance, power off during flight. We also wanted to increase the accessibility of the open source design we made and create tutorials for easy replication of our project.
So some of the improvements we've made on the system this summer, so starting with hardware improvements. In the command module, we implemented CubeSat board stacking technology. This is where the boards just stack on top of each other using through-hole pin connectors, and the connections between the boards are done through those through-hole pin connectors as well. So this allowed us to separate into different boards that have different functions. As of now, we have a power systems board that has all of the different power systems on it, as well as it connects to the battery. And we also have a satellite communication board that communicates with the pods over local radio and then relays that data through the Iridium satellite network to our mission control web server. And we also have a processor board or controller board that does all the processing and controlling of all of the components in the command module.
So we also made some changes to the circuit board designs. On the power board, we replaced some of the power regulators that used to be too tall to stack the boards well. We also replaced the Bluetooth module on the processor board because this one had become outdated, and we decided we needed a new one to communicate better with our web server. And we also updated the placement of some of the components to allow better board stacking and to decrease the radio interference between different components on the satellite board.
We also made some improvements on the battery. We did power calculations to calculate exactly how much power we would need for a flight. Doing this, we were able to reduce the battery size, which reduces the overall weight. We also redesigned the battery undercarriage to mount directly to the bottom of the power board, making the command module as a whole more compact and smaller.
We also made some changes to the software. With the embedded software, we added on-target testing so that you could either configure the balloon in the laboratory before flight or on the ground. We also updated and created libraries and functions for the components.
So we also made some improvements to the mission control software. We made it so that you can have the direct communication between the command module and the mission control. That's via the Bluetooth for close proximity. That would be used for the testing and configuration in the lab and in the field before a flight. We also updated the code to include data from new components that we've added, such as the battery life monitor. Okay. So this is a close-up of our diagram in the upper right-hand corner of our poster. As you can see, the balloon connects to the command module, and the command module communicates with the experiment pods via local radio. The experiment pods will be all different kinds of experiments that students want to do and that involve going up into the upper atmosphere. And then the command module then relays the data from the experiment pods to the Iridium satellite, and the Iridium satellite sends that data down to the Iridium headquarters in Tempe, Arizona, which then sends the data over to our mission control web server, where the data is processed and formatted so that we can view it. The mission control web server also communicates with the command module through Bluetooth connection. And as I said earlier, this is for doing pre-flight testing and configuration. The data that our most current version of the balloon system collects is the current time, the altitude, the latitude and longitude, vertical velocity, ground speed, and heading of the balloon, as well as it also collects the battery voltage, internal temperature, and external temperature. The data that the experiment pods collect will be specific to each student's experiment and will most likely be different every time we send up the balloon.
Overall, our research this summer was highly successful. The boards stack well. You can access battery percentage from the mission control web server, and all of the boards are grouped logically so that they'll be easy to make improvements on in the future. Speaking of improvements, despite how well our research has gone, Whitworth still plans to make even more updates to our command module. Right now, we're even looking at changing the container in which the command module is housed. Our current one is large, and with our new small, compact PCB stacking system, we're able to shrink it considerably and lighten it. We also want to make it more waterproof and sturdier. We're also thinking of eventually adding a secondary balloon-to-ground link radio, which can facilitate tracking in areas where you cannot get cell phone reception. Furthermore, there will be some more updates to mission control to add features like backwards compatibility with version 1.0.
Thank you for coming to our poster presentation of Whitworth's high-altitude balloon tracking system. We would also like to give a thank you to NASA Space Grant Consortium and SERP for giving us the opportunity to work on this project. And we would like to thank our mentor, Dr. John Larkin, for helping us and guiding us through our research this summer. If you have any questions, Meg will be here to answer them. Unfortunately, I'm getting my wisdom teeth out today, so I will not be present today. Thank you.